All right, we're going to continue our discussion about our parallelograms. Let's kind of review what we already know about parallelograms. We know that opposite sides are congruent and parallel to each other. We know that the opposite angles are congruent to each other. And we know that the consecutive angles are supplementary. And then the last thing about our parallelograms are that the diagonals bisect each other. This video is going to focus on special parallelograms. We're going to look at 3 of them. And as we work through the video, you might want to have handy your previous notes on the videos about parallelograms because we will use all of those properties today as well. So our essential question for our video will be, how can I use the properties of my special parallelograms to find side lengths and angle measures? Okay? How can I use the properties of special parallelograms to find side lengths and angle measures? We're going to start off with our rectangle. So you're familiar with a rectangle. You already know some of the properties. Well, your rectangle is a quadrilateral because, of course, it has the 4 sides. But what else do we know about the rectangle? It also has our 4 right angles. Okay? So if we take a look at our quadrilateral, we have our statement: if a quadrilateral is a rectangle, then it is a parallelogram. Okay? Because remember, we're talking about our 3 special parallelograms today. So you know that it has the 4 right angles. So you can see the properties of the parallelogram. The opposite sides being congruent to each other. They're parallel. Opposite sides are parallel. The opposite angles are congruent. Well, of course, they're all 90. And their consecutive angles are supplementary. 90 plus 90 is 180. And the diagonals do bisect each other, because that's a property of the parallelogram. Over here, our second property that we'll look at, if a parallelogram is a rectangle, then its diagonals are congruent. So now, not only do they bisect each other, but now they're congruent to each other. So if we bring in those 2 properties, what we end up with is 4 segments in here that are congruent to each other. So I'm just going to put in those tick marks. Okay? And if you look at that, do you see some isosceles triangles working in there? I hope you do, because we'll look at those later on. All right, so the other thing I want to point out is, since a rectangle is a parallelogram, don't forget all of those properties of parallelograms it has as well. Let's just look at an example. Okay, we have rectangle ABCD over here. We have that side BC has a length of 12 and side AB has a length of 5. Well, let's apply some of those properties we know. We know this is a parallelogram, so we know that opposite sides are congruent to each other. So I'm going to put in my tick marks. I know those 2 are congruent to each other, and I know those 2 are congruent to each other. Okay? I also know that the diagonals bisect each other, and the diagonals are congruent to each other. So I know that all 4 of these segments are congruent to each other as well. So I'll put 3 tick marks in for those. All right. So let's come over here. Question number 1, they want us to find length BD. So they want us to find this diagonal. Well, I know what half of it is. They told us that from E to D is 6.5. I know that this segment is congruent to this segment. Therefore, I know that BE is also 6.5. So I take those 2 segments, I add them together, I get 13. Therefore, I know that BD equals 13 inches. Our second one, they want us to find length CD. So I come over here, length CD, I know is congruent to length, or to side AB, which they told us was 5, so I know that CD is 5. Number 3, side or segment AC. Let's come over here and find segment AC. Oh, it's our other diagonal. We know that the diagonals are congruent to each other, so if I know that BD equals 13, I know that AC does as well. And our last one, segment AE. Segment AE, is right here. I already know that segment EC is 6.5. Well, I know that all of those are congruent to each other, therefore AE is 6.5. So those are some examples of finding side links and diagonal links with your rectangle and its special properties. All right, moving on to our second special parallelogram, and that is our rhombus. Some of you might be familiar with this one. This might be new for most of you. It is a quadrilateral because it is four-sided, but what's special about it is that it has four congruent sides. And here are our properties. So here's your four congruent sides. If a quadrilateral is a rhombus, then it is a parallelogram. So all those properties, again, of your parallelogram is going to come through. If a parallelogram is a rhombus, then its diagonals are perpendicular. Again, what does perpendicular mean? Remember, perpendicular means they hit at a 90-degree angle. So look up here. There it is. So you have all four of these angles in here are going to be 90 degrees. There's your perpendicular. And our last property, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So come up here, look at our tick marks, our arc marks. So we have that RT bisected these two angles here, and diagonal SQ bisected these angles here as well. Again, don't forget, since your rhombus is a parallelogram, we're going to use all of those parallelogram properties as well. Okay, let's take a look. We have rhombus KLMN. First thing we're going to find is the length of KL. Here's length KL. It's a side. What do we know about the sides? They're all congruent. So let's just put our check marks in. I know all those sides are congruent. They didn't give me side LK, but they did give me two sides. And I know by my tick marks that these two sides are congruent to each other. So how am I going to find my value of x? What are we going to do with those two values? Are you going to set them equal to each other? I hope you said yes. So let's come over here. We set them equal to each other. Combine our like terms. We get that x equals 8. I'm just going to sub this x equals 8 back into the 3x plus 4. So 3x, 3 times 8 plus 4 is 28. Therefore, if my side LM is 28, what do I know about the other three sides? They're also what? Did you say 28? You got it. So length side KL is 28. Now let's look at an angle. We want to find angle MNK. So MNK, we want this whole angle here. Okay. Well, we see this diagonal. Remember what we know about the diagonals? It bisects the opposite angle. So I'm going to put tick marks in so I know that this angle is congruent to this angle. All right, well, they gave me the 2y plus 5, but I don't really know or have any other information here. So I need to find something else. I've got a y here. I've got that this angle here is a 9y. Do you know something about this angle? Let's look back up here. Are those diagonals perpendicular? So we know that this 9y equals what? Whoops. Did you say 90 degrees? I hope you did. So 9y equals 90 degrees. So let's set up our equation. So now we know that y is 10. Now I can substitute that 10 into my expression down here. So if I put that in, I get 2 times 10 plus 5 is 25. So if I know that this angle measure is 25, I also know that this one is 25. So I add those two together, and I get that my angle MNK is 50. And our last special parallelogram is our square. Why is our square so special? It is special because it takes the property of the rectangle, the four right angles, and it takes the property of the rhombus, which are four congruent sides. So if you take a look down here at your diagram that we've given you, your square takes those properties of the rectangle, and it takes those properties of the rhombus. It takes the congruent sides here. It takes the right angles here. So the square encompasses the properties of the rectangle, the rhombus, and the parallelogram. So he encompasses all of those values or all of those properties, and he in himself is a very, very special parallelogram. So we're going to stop right here. I want you to make sure you fill out your whisk, and we will talk about the square when I see you again in class.